So, greetings everyone. My name is Zonglin, and I'll be representing the representing our team. Be right back out camping. So, as the name suggests, two of our team members are actually out camping. So, we we have pretty much three people currently working on this project. So, a little bit about this project. So, first of all, the NCHA has reported a increase in the number of people with mental health issues recently. So typically, if you have some kind of a mental health concern, you'll go to a physician, and usually they'll do a whole bunch of diagnostics, and it'll take a pretty long time, and they'll get back to you on your condition. So our challenge was to develop a system that's more automated, right? Like quite a bit quicker than having to go to a physician. So what our project involves is to train a neural network to process through EEG data and try to predict whether or not the patient has depression. So currently what you're looking at right here is the data indexer. So what that does is it just indexes all the file paths of where the training data lies, as well as it performs a one-time pre-processing. And the pre-processing, what it does right here, let's see, right here. So the pre-processing, what that does is it's going to take the time domain data, and it's just going to divide it into 8-second chunks, okay? And for each 8-second chunk, it's going to perform a fast Fourier transform and convert it into a spectrogram. And a spectrogram is essentially the sort of the three-dimensional tensor that we're feeding it into our convolutional neural network. So in terms of the ConvNet, we took some off-the-shelf networks, for example, the EEG net, as well as some more EEG nets. There's a whole bunch of EEG nets, and then there's like the deep ConvNet as well. And we tried those ones, although those ones, they aren't really they weren't really designed around spectrogram data. They were more so designed around just taking in sort of the raw time domain data and kind of stacking it together to form a tensor. So what we did was we ended up just creating our own model. We called it FFT-conv, and it's a pretty simple convolutional model with 3 convolutional blocks and then 2 more dense layers. And currently we're training it, and last night I just kind of let it to train and try to search for hyperparameters, which ended up not working out too well, but so far we've able to get it up to 60% accuracy, which is really not as high as we would want it, but I mean, typically 24 hours is very, very short amount of time to develop a neural network. And we're actually kind of lucky that we get to have our own computer to train on rather than having to use Google Colab, and surprisingly our computer is a bit faster than Colab's. So even then, it's still a time crunch. So the data set was taken from OpenNeural. It's a open source data set containing data from 122 different subjects. So each of them recorded about 30 seconds, or sorry, not 30 seconds. That would not be enough, but like 30 minutes of EEG data from 64 sensors plus 3 auxiliary sensors